We saw an example similar to number 5 just a moment ago, and the way we approached it is we rewrote the function. We moved this piece up to the numerator and changed the exponent to negative 1/3. However, in that example, when we did that move, what we had was a constant multiplier. Well, here we don't have a constant multiplier. We have a variable. We have something times something. If we were to get this derivative, we would need to use the product rule. Well, I'm going to give you a great tip right now. Don't ever use the product rule in an attempt to dodge using the quotient rule. I can use the quotient rule here, and I promise you it will be more efficient than using the product rule with that negative exponent. So let's see how this plays out. The derivative will be the bottom times the derivative of the top, and the derivative of the top is 1. And then minus the top, which is x, times the derivative of the bottom, and for the derivative of the bottom, I'm going to need to use the chain rule. I'll put the 1/3 in the front, then I'll put the x squared plus 4, and I'll subtract 1 from my power. 1/3 minus 3/3 is negative 2/3. And I then, of course, need to multiply by the derivative of this piece. The derivative of x squared plus 4 is 2x. And that's all over the bottom squared. So I have to take this x squared plus 4 to the 1/3, and I need to square it. Before we look at that numerator, let's clean up the denominator. Something to a power, well, you multiply these powers. 1/3 times 2 is 2/3. Let me highlight that subtraction symbol in the numerator. And now hopefully you see that over here we have something times something times something times something. All of this can be expressed as one fraction with positive exponents. I'll put the 1 in the numerator and the 3 in the denominator. This x goes in the numerator, and so does this 2x. So in the numerator, we'll have 2x squared. And this x squared plus 4 goes in the denominator because it has a negative exponent. I suppose 1 times 2x squared is just 2x squared. Since this piece is a fraction, I might as well express this piece as a fraction too. This is x squared plus 4 to the 1/3 over 1. Now let's tackle this numerator where we have a fraction minus a fraction, and we can use the Macfarlane method for subtracting fractions. My new denominator is 1 times this. And my numerator will be this times this, so it has a 3, and then x squared plus 4 to the 2/3 times x squared plus 4 to the 1/3 would be x squared plus 4 to the 3/3, or just x squared plus 4. Then I'll put my minus, and of course 2x squared times 1 is 2x squared. That's of course all over the x squared plus 4 to the 2/3. Let me distribute this 3. This would be 3x squared plus 12. And of course 3x squared and negative 2x squared are like terms, so my numerator here would be x squared plus 12. So I have x squared plus 12 over 3 times x squared plus 4 to the 2/3, and I need to divide that by this, which means I need to multiply it by 1 over this. So I think we finally have it. My numerator is x squared plus 12 times 1, and my denominator is 3, and then x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3 is x squared plus 4 to the 4/3. Look at that. Perfect. Let's take a look at one more example that we can differentiate using the chain rule. All of this is to the power of 2. So let me begin by moving the 2 into the front, and then I'll put all of this to the power of 1. But then I need to multiply by the derivative of this, and for that, I'll need the quotient rule. So I'll put the bottom times the derivative of the top, which is 3, minus the top times the derivative of the bottom, which is 2x. And I'm going to put all of that over the bottom squared. The first thing I want to do is clean up this numerator. So I'll, of course, distribute this 3. This is going to be 3x squared plus 9. And then I'm going to subtract what I get when I distribute the 2x. Let me put that in parentheses. 2x times 3x is 6x squared. And of course, 2x times negative 1 is negative 2x. When I distribute this negative, this will be negative 6x squared and positive 2x. And now I have some like terms I can combine. Of course, negative 6x squared and 3x squared is negative 3x squared. And then I have my positive 2x and my positive 9. Now, let's see what we have here. In the numerator, we have a 2, we have a 3x minus 1, and we have this negative 3x squared plus 2x plus 9. And in the denominator, we have an x squared plus 3 and an x squared plus 3 squared, so that will be an x squared plus 3 cubed. No need to foil our brains out. As you can see, we got it correct. All right, now it's your turn. Go ahead and get those try these done.